it's the same with commercial buildings. Like before you're talking about upgrading that chiller, how are your filters clean? like what's your tower look like? And, what's the water cleanliness of the water in your chill water loop? And, this is the basic stuff. Like I think, as engineers, we tend to kind of move away from that. We want to, so the air curtain kind of falls into that category for me. Like it's a very simple thing. The ROI, we'll talk about that in a minute. I'm sure it's very, very quick, especially if you're in like a real humid or a real severe climate. Here in North Carolina, we're kind of mild, but it still could be helpful. I walk down the street all the time in downtown Asheville, and the doors are wide open, and it's summer and it's humid out. And
in those type of applications too, especially like with freezers or things like that. I mean, it's very important to have an air curtain to keep the humidity out or the temperature change, because especially if you have product that's on the other side of that seal, you'll start to affect the product too, right? We've had some customers that have had this issue. They didn't have an air curtain, but they're, what was happening, the temperature differential, whatever happened, the humidity would catch on the product, and then the product was getting rejected.
Welcome to the Engineers HVAC Podcast, where our mission is to empower and educate the HVAC community. This podcast is brought to you by Insight Partners and Hobbs and Associates, two commercial HVAC rep firms. I'm Tony Mormino, your host for today, and today we're going to be discussing the wonderful world of air curtains. And I have two air curtain experts here. I'm going to let them introduce themselves, Sami and Mathu. Sami, why don't we start with you, a little bit about what you do and where you're at, where you work.
Hey, Tony, thanks for having us. And guys, I'm Sami Aslam. I'm the product manager for air movement product for Schwank North America. We're located here in beautiful Mississauga, Ontario, Canada, so Toronto. And we have another facility up in Winsboro, Georgia. So thank you.
Awesome. Thanks for being here, Mathu.
Hi, everyone. My name is Mathu Baskaran. I'm the manager for the design and application engineering team. Our team is primarily focused on helping engineers, even our own applied reps, and all our customers basically on how our equipment fits into your design. So basically we can do heat loss calculations when it comes to the heater side of the business. When we look at the air curtain design, we look at doors, maybe even how the doors are positioned. We look at all that stuff, and basically we would help anybody out there who needs a design made for a climate system, including the controls too. So that's what our department does.
Excellent. And are you in Ontario as well, Matt?
That's right. Yes. Also located in the same office as Sami in beautiful Mississauga, Ontario, just outside of Toronto.
What's the temp up there today?
I'm reading 5 degrees Celsius right now.
Okay.
Yeah.
And it's dipping.
It's going to get a little cooler before it gets warmer. That's how our spring is always. Yeah.
Gotcha. Well, I'm up here in the mountains in North Carolina near Asheville, and I don't really think it's going to be 70 something today. So it's going to be pretty warm up here today. So
jealous.
A little different than Ontario. So you have to come down and visit, get some warm weather.
All right.
All right. Well, let's get right into it. So air curtains. We haven't talked about air curtains on this program before. Honestly, I've had little experience with air curtains in my career. I know they're very useful when you need them. And I see them in facilities. You go in and you get this air blown on you and your kids are like, what the heck's that thing? And I'm trying to explain it. And I know, enough about it to maybe explain it to a 13-year-old. But so this is good. So thanks for coming on. So let's just start with the basics. What is an air curtain?
For sure. So air curtains, again, they create they're units that, like you mentioned, Tony, outside above your doors, and they create aerodynamic feel between an outside and an inside environment. So what they do is they make sure that no outside, basically dust, fumes, let's say colder weather, cold wind, they don't come inside. And in return, your conditioned air, so your heating, your cooling, they don't leave the facility. So that's basically the main principle around air curtain. It does a comfort, employee and customer comfort, especially in the facility. It saves you a lot of energy, especially if you have doors that opens and closes a lot of times throughout the day, like your coffee shops or, your grocery stores, industrial dog doors, all of these things.
Yeah.
I mean, it's very important to know that everybody spends a lot of time on their chill water system or their boiler system. They try to focus on maintaining that conditioned space, and it's good, it's fine. But then what you forget is some things that are out of your control, right? When people come into the office, or when the dock doors are open, you're getting deliveries. It's nice that you have a variable speed system. It's nice that you have intelligent controls that would react quickly to these changes. But then how about minimizing or trying to offset those changes that you don't have control over? Yeah. Right. And so when those doors are open, you can't control that. You're not going to put a lock. Okay, you got to wait for 5 minutes before you enter the door in, because we could save money on our HVAC. And that's when the air curtain seals come in, right? That's the whole idea. Yeah. Hey, listen, maintain your space, because you spent money on trying to get that space at a certain temperature. And now when the door opens, that's money that's gone. So why not try to keep that seal? Just like what Sami said, it's an actual climate separation seal, using technology that's very low amp draw, very low cost consuming style technology. And then just create the seal and then maintain that space, right? Maintain that temperature. So you're not having any air dissipation, basically.
Exactly.
Yeah. So a couple things are coming up for me there. So I'm really big on we get a lot, and I can do this with my own home, like my own life. Like I want to have this expensive VRF system, and I want to do all this stuff and people are like, how about your windows? How's your insulation? You know what I mean? It's like, it's the same with commercial buildings. Like before you're talking about upgrading that chiller, how are your filters clean? like what's your tower look like? And, what's the water cleanliness of the water in your chill water loop? And, there's the basic stuff. Like, I think, as engineers, we tend to kind of move away from that. We want to, so the air curtain kind of falls into that category for me. Like it's a very simple thing. The ROI, we'll talk about that in a minute. I'm sure it's very, very quick. Especially if you're in like a real humid or a real severe climate. Here in North Carolina, we're kind of mild, but it still could be helpful. I walk down the street all the time in downtown Asheville, and the doors are wide open, and it's summer and it's humid out. And
in those type of applications too, especially like with freezers or things like that, I mean, it's very important to have an air curtain to keep the humidity out or the temperature change, because especially if you have product that's on the other side of that seal, you'll start to affect the product too, right? We've had some customers that have had this issue. They didn't have an air curtain, but what was happening, the temperature differential, whatever happened, the humidity would catch on the product, and then the product was getting rejected.
So I'm from Florida, and I can tell you, when you open that door to the outside air in the summer, it is like a ton of bricks that hits you with the humidity. I mean, it's palpable. If someone who's not, when I moved to North Carolina, it was like, I think we moved here in August, and someone was like, "Oh, you'll get used to the humidity here." Man, this is a joke. In Florida, you go outside and your glasses steam up because their glasses are 72 degrees or whatever, and the dew point's higher than that almost all the time in the summer. So, I could see, and the heat is not really the issue when it comes to cooling; it's the humidity. So if you can keep that humidity out. Which I'm sure an air curtain helps with that, because it removes the vehicle of the air to pull the humidity in the space, right?
Exactly. Yeah, that's exactly what it does. So that's basically the main principle or the main idea of an air curtain. And again, they work on various different principles. They work on thermal separation, environmental separation, wind resistance. So these could be various different principles. And then the main idea around that is, how much is the velocity of the air curtain that you're providing? So where are you mounting it, and what's the velocity? And basically what's the building pressure like, and the entrainment. So basically how much air is leaving the building. So those are the principles that we try to design the air curtain around.
You can see how much engineering. It's such a simple device that everybody takes for granted. You walk in and you feel it right when you walk in through the door, but the amount of engineering that goes behind it, like the blower selection, the fan, you have to look at these obviously these fan curves. You're trying to extract the most out of the blower with the least amount of amp draw. So depending on your motor, what kind of motor are you going with? And then there's also, well, can I get more out of my nozzle design? How do I design my nozzles? Because I can dump more CFM into the blower, so I can size the blower larger.
Mm-hmm.
But is that really the way to go? Because now you got higher RPMs, you might have more amp draw, or can I do something smart with my nozzle design, right?
Mm-hmm.
And then do something a bit different and see if you can get a nozzle effect going where you're shooting out a little bit more, like things like that. It's very, it's such a small device, but the amount of engineering that actually goes into it is actually kind of impressive. And then what Sami mentioned, which is a huge thing, which is mile per hour. What happens if you have a crosswind, right? These dock doors sometimes are rated a little higher. So you need to stop that wind, like that, whatever mile per hour, 10 to 30 mile per hour wind. So it's a lot of engineering that goes into that one little unit, right? And then there's also supplementary heat too, right?
Exactly. Oh yeah, we haven't even gone to that part. Yeah, the supplementary heat. And so I'll jump into applications for a second, and then I will discuss the engineering principle around it, if that's okay with you, Tony.
That sounds great. Let's hit a couple common applications because I have some questions there. So.
100%. You will see air curtains, or I must say you need air curtains, anywhere from a drive-through window all the way to a door where you can almost pull in a vehicle. So one of those large bay doors, basically,
right,
where trains come in, where, I don't know, trucks come in. So air curtains could be anywhere between these applications. How we like to separate air curtains is from its mounting height. So every application comes with a specific mounting height. So if you have a drive-through window, it might be a 5-foot mounting height, 4 feet mounting height. So we have an air curtain for that. And then commercial typically is anywhere between 8 to 10 feet mounting height. So commercial as in a coffee shop, a grocery store, et cetera, any commercial applications. And then after that, you get into more of an industrial / heavy commercial, light industrial setting. So it could be a 12 feet mounting air curtain. And then you get into industrial units. So 14 feet mounting, 16, 18, 20, 24, the list goes on and on. So the interesting thing here is how we design the air curtain is very important because you need to make sure you get enough target velocity at the ground level. Like Matthew mentioned, when we select blowers, when we select our motor, when you select the right horsepower, the blower size, the wheel size, etc., you need to hit a certain feet per minute, so air velocity number at the ground level, or else your air curtain is not designed properly, basically.
Or the air from the inside can go out and the outside could come in, right? If you don't have the right velocity through the whole wall of air, basically.
Exactly.
So help me with let's double click on a couple of these applications. So the drive-through window, first of all, the height, when you talk about 5 feet for the drive-through window, is that to the floor or to the bottom of the window?
The bottom of the window, because that is considered
the area that you're trying to block.
Yeah. At the end of the day, the air curtain will only work or provide shield when it has a surface at the bottom. It could be a kitchen counter or a drive-through counter, or it could be the ground in case of a door. So once it hits that surface, that's when it creates a seal.
I see. I didn't understand that. So do a lot of drive-throughs, I don't know if I ever even noticed them. Maybe all the drive-through have them. Do they all have them and I just don't see them? Because I'm thinking of this big turbojet thing, but they're probably a lot quieter than I'm thinking. And
good. I think what we're trying to say is they should have them. I mean, even from an employee comfort perspective, every time that door opens, sometimes you've seen them when you get your coffee. The person at the window is wearing like the stick parka jacket, right? Because she or he has to be the one that has to stick their hand out. They're frozen in there, but they should have one because what? Once you have that climate separation, you got one with a little bit of supplementary heat to provide that little bit of heat. Then they don't need to wear that parka, but they should have one.
Exactly. So they most of them, at least from what I've seen, any of these big chains, Starbucks or whatever coffee shops, they do have an air curtain. Sometimes you'll see them mounted outside, like in a stainless steel housing. Other times they're inside, right above where you can see it. And again, they're not, at any given moment, your target velocity at the ground should be anywhere between 400 feet per minute to 800 feet per minute. Anything less than 400 feet per minute basically means you don't have a proper seal, air will go out. Anything more than 800 feet per minute basically means that you have a lot of air, it's creating a turbulence at the ground level. And when it creates a turbulence, it's still not an effective seal. So for us to have an effective seal, you need to make sure you're anywhere between 400 to 800 feet per minute. And that number is basically described by the Air Movement and Control Authority. So AMCA, we like to call it. And so any of these, let's say the drive-through air curtains, the reason you don't hear them is because they're so close to the surface level that they're basically running at much lower speed, meeting that 400 or 500 feet per minute at the ground.
Right, I gotcha. Because it's just a small window. It's not like a 10-foot area where you've got to shoot the air all the way down, so you're hearing a lot more noise.
Exactly.
Oh,
You've got it.
That explains why I don't.
Yeah, and then in addition to that, the supplement heat that Mathu talked about, that's a big, big deal. So air curtains, they're available in ambient, electric heated, and water heated models.
Oh, really?
So water heated, if you already have, again, your boiler systems in the place, you can just have it comes with a heat exchanger, heating coil, just connect the pipes in, and you have a water heated air curtain. It comes with electric heated, so you have open or most of them open finned elements inside the discharge of the air curtain or at the intake level, and they provide supplement heat, where in some cases, in commercial settings, we'll discuss that, but in the commercial settings, you can almost use it as a space heater in some conditions, where you need to, let's say it's a little bit cooler, air curtain turns on and it will keep running until you meet the X percentage or X degrees Celsius or Fahrenheit that you basically need. So yes, you could use that as supplement heat, or it's available ambient without any heat if you just need climate separation. There is absolutely no difference in terms of climate separation between the heated and non-heated models. The main purpose of heated models is basically to provide comfort to the occupant comfort. So if it's a little bit heated, where the cold draft of wind is, it will stop the cold draft of wind and also give a little bit of heat at the same time. So that's basically the main purpose of heated air curtain.
I think the main thing is it's supplemental, right? I mean,
supplemental.
Some people, I mean, it's a very small space heater. I think there are better options for heating personally, but still it's, hey, if you want to temper an air because there's air in the airstream and you want to just sort of temper it, then that's what it's for, right? Yeah. There's still like, what are they, Sami, the thin tubed, a lot of those. So some of those, if you really put them in a spectrum of heating scales, they're efficient to a certain point, and then they exponentially can start to draw more power, right? Then you have to really look for an alternative method for heating. But I think a lot of engineers also just tend to think that, hey, listen, I can probably use that air curtain, and then I can back off on something else, save the money, because the air curtains tend to be a little bit cost effective, right? So then let me use that as my perimeter heating, and see what I can get most out of that. But then in that case, you might be going with a larger air curtain. You might be drawing a lot more power.
Right. And I look at the heat in the air curtain, and correct me if I'm wrong, as a safety against very cold temperatures outside. It's kind of a neutralizer rather than a heating.
Basically, that's a very nice way to look at it. And imagine someone is loading a truck. Someone is working in the loading dock. They're loading up a truck. Now they're going between in and out of the truck. That side is cool. Their dock area is warm. Now, at least with the air curtain blowing air, as they're passing through, they still have that warm feeling. So yes, it is a neutralizer in some sense.
It's taking the ambient air anyways, right? The conditioned space air, and it's throwing it into the air curtain and recycling back out. So if the air is at the right temperature, the right set point, all we're doing is just basically recycling it.
Right.
If you wanted to temper it, you could, but essentially, is there a huge need for it? I mean, it depends on the size of the door. Maybe on a commercial property, smaller doors, it might make sense. Drive-through definitely makes sense. But when you get to the dock doors, I think that we're starting to look at efficiencies and performance. There's other options there. Radiant heating for those type of warehouse spaces works much better, effective heating compared to using a massive dock door air curtain coil, right? I don't know if that's effective, a good use of energy, but it's available because people ask for it. So have it available, right? So
that's good. So let's talk a little bit about like the performance, the application of these. So the drive-through window, and then we'll talk about the dock doors, which seem to be two very common applications. And also, when I go by some stores, they want to keep the doors open in the malls, outside malls, to attract people in, right? So that's another application. So the drive-through window, this thing engages when the door opens, and then when they close it, it shuts. They're usually linked to the door. Is that correct?
That is correct. Absolutely. So air curtains, they come with door switches. So for commercial applications, they're typically plastic magnetic switches. And for industrial applications, you can get industrial magnetic switches, you can get roller type magnetic switches. So again, these are all activation options. So yes, they do come with switches. And as soon as the door opens up, again, the magnetic switch demagnetizes, if that's the right word. And then the air curtain will kick right in and provide seal right away.
Right.
Basically, like your normally closed condition, right? So normally closed, which means the door.
Right.
And once the circuit's broken, it detects it, and then the air curtain's like, so the door must be open now, and then it goes into an on mode activation.
Correct.
Got it.
And in addition to that, now if we think about situations like you mentioned, Tony, where they want to promote something, they have doors open all day. So yeah, that's definitely possible. Again, A, because of the door switch, and B, part of the control strategy or part of the controls that at least we offer, you have different options on your touchscreen controller where you can leave the air curtain on, you can leave it in a certain timer mode where basically you have it on for 2 hours and then it goes back to its normal condition. You can use it as a space heater. If let's say the door is open constantly, you turn it on, use it as a space heater to warm up the area constantly. So there are all these options available, part of the controls. So again, air curtain, it's important to understand that air curtain is not just, like a fan in a box, basically. There is a lot more to that. And when I say a lot more, it's basically the type of motor you're selecting, the sound, the control strategy, how the type of controller you're using. So there is a lot of things that basically makes this as the perfect product.
Right. And as anything else, you get what you pay for. So if you've got a real high-end store and you want something that's kind of out of sight, out of mind, controllable, make sure you're doing your homework because they're not all the same.
Actually, one thing that you said out of sight too, and part of the air curtains, what's also offered. I mean, you can have one that sticks out that's just sticking right above you, or you can have recess style too, right? So out of sight is completely out of sight. It's right in the wall. It's dry-walled up, and all you see is a little thin, basically the nozzle opening. So when you said out of sight, I was like, we didn't even talk about the recess style air curtains, but there's that option there as well. Yeah.
And now you said you can use these if the door's closed. Can you run them to just heat the space? Did I hear that correctly?
Correct.
Okay.
You could do that. So depending on the sorry, go ahead, Matthew.
No, you go ahead.
Yeah. So depending on the type of unit you select, depending on, let's say, what control package you select. So for example, we have basic versus advanced. And each of them, they come with their options. But yes, you're right. You can basically turn them on from the controller and use it as a space heater until you achieve your whatever comfortable temperature you're looking for. Let's say 22 degrees Celsius or 76 Fahrenheit, whatever you're looking for. It will keep running until then.
So just like a thermostat control while the door's shut. So on the touchpad, you mentioned a touchpad. So I'm assuming that's an option you can get with these. If you have a bay with 5 doors, you can schedule them all, tell it to come on when the switch opens and when it's closed, control to this specific temperature.
Exactly.
So you can see with those bay doors though now when you're dealing with a large space, right? I mean, you have to really see, am I going to achieve or hit that set point? So then this air curtain could be running all the time. And this is where we're trying to separate. Hey, listen, is it really necessary on some units to have the built-in for the space heating, or go to another option? Like I said, radiant heating is a good option around those bay doors. Maybe not the space heating option, but then in a commercial application, a storefront, there shouldn't be any issue there.
Correct.
Gotcha. You got the option. There are a lot of options. Yeah, definitely.
Yeah. And now let's talk a little bit more about, let's say, commissioning part or installing part of it, because air curtains are as good as how well you commission them, how well you install them. And that's very important. That's like one of the most important things about air curtain. When I say that is, let's say a door size is 8 feet. You got to make sure that your air curtain is not less than the door width. It can be a little bit more, that's okay. But if it's less, then it's not doing its job, because then you have that extra inches or the feet, whatever, on either side where the air is escaping, and you're basically almost messing up your entire seal.
Right.
So we need to make sure that your air curtain is the right door size. If let's say you have a door that's 8 feet wide, and I don't know, if there's no air curtain for 8 feet wide, it's okay to install a 9 feet wide air curtain, but it's not okay to go a size lower.
So
that's
the
very
two
important.
things we need before anything is the height and the width of the door. Is that right?
Basically.
That's it.
Okay. With that, can you select any of the products?
Exactly.
You can. I mean, do we want to do a detailed analysis and try to understand? You can get design temperatures if you look at the ASHRAE data, so we know location. Then we can do a little bit of an analysis. But from a high level perspective, just hey, I need a rule of thumb kind of thing. Just I'm with a customer and I just want something real quick. Yeah, then the basics would be the height and the width.
The height and
at
the
a high
width.
level.
Yeah.
Yeah.
And height and width.
Is there a filter in these products?
Yeah, you can get a filter as well. So filter is an optional accessory that you can opt for, and definitely you can get a filter with these. Now, part of filter is obviously your maintenance goes up. So what I've personally seen is if I go to my local hardware store, I see units, a lot of units out there that no one goes up to clean them, and the units are almost choking. Like when I say choking, they're like the motors are struggling to suck in air from the intake because there's so much dirt on it. They're not really giving you any climate separation. They try to turn on, you hear them whining, and there's some air coming in, but you might as well don't run the air curtain at that point.
Yeah.
So yeah, with filters, it's available 100%, but then you need to make sure that you have a proper maintenance procedure installed for your facility for air curtains.
I'm laughing because I thought you were describing my filter in my home AC unit, which I probably need to. Usually I change it when the coil freezes up. I'm like, oh, time to change the filter. It's totally pathetic. It's just terrible.
Preventative maintenance is a hard thing to sell. It's very hard to sell, but
Matthew.
it's required for good equipment operation and keep the performance up, right?
We were talking about that earlier. Like, how is your water quality? How are your filters changed? All these very basic things, extremely important.
I was just going to touch upon the preventive maintenance part. Yeah, thank you, Matthew. Exactly. You don't have to go every time up there and clean the air curtain, but that's preventive maintenance. If you do that, your air curtain will last forever, because again, there's nothing with the fans that can go wrong. And there's a motor in there, correct? And the part of that is proper maintenance. So make sure that your filters are clean, your intakes are not choked up. Once in a while, open up the top of the air curtain, just clean it up a little bit, clean up the motor a little bit. And in that way, it will last forever because part of our innovation about air curtains is moving into EC motors. And the reason we're choosing EC motors over PSC or AC motors is because we want reliability in our products. That's very important. We don't want your standard product where, you have a typical motor and it's breaking down. And part of all that is combined efforts, right? We can do only so much on our end selecting the right product. So for example, EC motors, all of our, let's say 12 feet up to 24 feet air curtains are EC platform. So, and the reason for that is mainly because it's energy efficient. Yes. It's, there's much less heat dissipated from those motors, especially during startup and stop. So what happens is you don't have that much degradation in the motor. Your components have much more lifespan on it. And obviously with the proper care and maintenance, these air curtains can go anywhere up to 15 years as well without any issue. And again, if you face any issue, all you have to do is, again, swap out the motor. The air curtain keeps running again. So the lifespan is much longer of air curtains if you take care of them, choose the right product from the get-go.
So are the motors variable speed? I know EC motors are by nature, but so when it starts, it slowly ramps up and it slowly ramps down, I'm assuming, so it doesn't. But does the variable speedness come into account when you're just using it?
Yeah.
Or is it just full speed the whole time? Or how does that work?
No. And to be honest, it's not full speed. That's what we see in the industry today. And I really want to point that out. What we see in the industry is more is good. And that's not true. Like we will see units out there where it's one speed unit. It will just blast air and God knows how much feet per minute they're achieving at the ground level. It's like ridiculous numbers. And that's not good. Because
you're defeating the purpose of this is to provide some kind of ROI with energy savings. There's other benefits of keeping the bugs out and comfort for the employees. But and if you're just, a fan blowing at full speed is using a lot of kW. a lot
Exactly.
of horsepower. So
That's
We
where
see that
we
with a
use.
lot of. Sorry, go on.
No, Matthew, please go ahead.
I was going to say, no, we see that with a lot of like the CFM, especially. I mean, one is the feet per minute is the actual velocity, but also CFM. Like a lot of people, it's funny when you say more is better. I just think of Tim the Toolman Taylor. I don't know if you guys know that home improvement. He was always about just more power.
You're
more
dating
power.
us. You're dating us now.
I've already.
There's a lot of people are like, Tim the Who Man, what? What's
Yeah, I've already dated myself. But I mean, when that was the mentality. I just need more airflow, and it's a complete waste of energy when you have if you're just trying to dump that much CFM or trying to get more speed, always working at maximum values or whatever. It's a complete waste of energy. Sorry.
What we do is exactly like Matthew said. We understand that how much we need how much velocity we need at the ground level, and we take it a step further. So we take our product. We have advanced controls with most of our air curtains, especially on the commercial and industrial side. And with our advanced control package, you can get outside temperature sensors. Because of EC motors, we can vary the speed. We can vary the speed based on outside temperature. So when the outside and inside temperature is close, like the delta between the outside and inside is almost negligible, our speed starts to ramp down because you don't really need that much climate separation.
Wow.
It's still maintaining the 400 feet per minute because you still need separation, but maybe you don't need a very high speed. Like if our normal was 600, we have to be anywhere under 800 and above 400. At our full speed, let's say our speed was 600, 650. With our control strategy, what we do is we ramp it down or vary the speed based on temperature outside. So if the temperature is very close to the ambient, we bring the speed down, and then the air curtain just runs enough to provide the 400 feet per minute. So we vary the speed. And what that helps is you're not running the motor at, 100% at all times, but you're also saving the life of the motor. If you think about it that way, with the separation, your input kilowatt, your power draw is much less. You don't need all that.
Yeah. It's a cubic relationship to the RPM. If I'm thinking of my fan laws, right? But
yep, that is right. Yeah,
it's a huge cost savings, and then also the acoustics of it, which could be a major deal. So is that feature built in with it, or is that an option, or is that a separate panel, or how does that work?
It's all built in. You just again, part of the controls is either you choose a basic control or an advanced control.
Oh, I see.
And advanced is what comes with all these basically bells and whistles. So everything you can imagine. In fact, we have different things. For example, traffic mode. So if it's in a commercial setting and someone walks in and out, it's an outlet mall. It's a busy day. You have sales going on. Someone is walking in and out. So instead of turning off the unit all the time, providing, ruining your motor, we have a high traffic mode. Once the unit judges that, let's say there is 10 instances where the door was open, close, open, close, open, close. Instead of shutting down the unit within that 2 minutes time frame, it just goes to a much, much lower speed where your amp draw, your draw is negligible, but still running. And it ramps up pretty quick as soon as the door opens.
Basically looking at the frequency, right? It's basically looking at the frequency and then trying to say, hey, listen, it doesn't look right. It looks like I'm always on. So let me stay in this comfortable spot. And then when the frequency changes, then it'll adjust itself accordingly.
Wow, I had no idea. Like there was that sophistication in air curtains. So.
Yeah, it's a lot. You can connect it to your building management system. We have BACnet or Modbus. Again, you can connect it to your door, like we mentioned. So you can do a lot of things. You can do scheduling with it. You can just go in your schedule calendar, plug it in when you want it to run. It can do that. It has summer and winter modes. So based on summer and winter mode, heating will kick in when it only needs to. If there is no heating needed, it will only do climate separation. So it's like I said earlier, it's more than just a fan in the box. It's basically a lot more that goes into it to make it the product that it's supposed to. So save energy. We can't just run the motor 100% and be like, oh, it's saving you energy. No, that's not the case, because you're willing to put brains and controls into it to make sure it runs right.
Excellent. I love it. Well, that's great. I think we got a good general feel for the latest and greatest in air curtain technology. It's certain I have learned a lot. And, so how can the listeners and viewers learn more about air curtains and other Schwank products?
For sure. We have our YouTube channel, Schwank North America. We have our Instagram. We have LinkedIn. So yeah, please come to our channels, and you'll get the most updated information about our products. Additionally, we do webinars, and come to our LinkedIn page. You'll guys see a registration link for our May webinar, and register. We'll be talking about air curtains this webinar. It will be around the standards and codes for air curtains. So that's basically going to be, how do air curtains come into codes? How can you save on vestibule expenses? Because if you have an AMCA certified air curtain, you don't need a vestibule in your building. So, that's a huge cost saving, $100K versus minimal cost for air curtain. Energy rebates. So that's a big one. Your ROI from 3 to 4 years can come significantly down with energy rebates, at least in our area in Canada. You get energy rebates for air curtains, but definitely in US and California, everywhere as well, there are rebates available for air curtains.
The other way also, Tony, is if you jump on our website, there is a link for like design assistance. We have different forums. There's one for air curtains, but there's also stuff for the heating side, and we also we have a line of HVLS fans as well. That's a good way to get in touch with us if people want to know a little bit more. What we do is when people register on that website, it kind of goes into a lead generator. We have an internal tool that goes to our salespeople, to our marketing team, and then they will be in contact with somebody from Schwank to discuss any topic that they want to talk about or any of our product line. So that could be done right on our website.
Excellent. And that's schwank.com?
It's schwankgroup.com.
Schwankgroup.com. And the LinkedIn is it Schwank North America on LinkedIn?
Correct. It's Schwank North America on LinkedIn.
And you're very active on Instagram as well, I see. What is that handle? Do you have that in front of you?
Schwank.North America. So LinkedIn is Schwank North America, and Instagram is Schwank.North America.
Excellent. All right. So go check those resources out. They do a great job of providing video tutorials, and their YouTube channel has some excellent videos on these products, the air curtains, and their other products as well. And Sami and Mathu, let's do this again. This was great. Thank you so much for joining us.
Thanks for having us. Thanks for having us. Lots of fun.
Yeah, it was fun.
Thank you guys. And thank you all for listening. We appreciate you.